All right, welcome to Texas Voice. Today we're going to be talking a little bit about the Great Pyramid of Giza. This is going to tend to be very controversial, especially on a forum like YouTube, where I'm sure every conspiracy theory and every wild and crazy idea is there for all to see, and that's probably the majority of what you're going to find when it comes to ancient stuff like this. It's very easy to come to those wild conclusions because we do have so little information. We're talking about thousands and thousands of years ago, and something like the Great Pyramid is obviously a gigantic and complex structure. It lends itself to this sort of thing. Okay, I'm going to go over some of the mathematics because I'm kind of in the camp of people that think that the generally accepted view is fundamentally limited at best. And it's very easy to get lost in the numbers when you're talking about a very large and complex structure. All kinds of things can be coincidental, and that's really the general argument against a lot of these, the number-based theories that come out that go, well, it's coincidence that this would happen. I argue that there are some things that are far beyond plausibly coincidence, and I'm going to go over one of those things right now. This may be a series that I explore deeply, I don't know. This is all stuff that I haven't really looked at in probably 20 years, but I thought it would be nice to get it out there. I think there are probably some people that are still interested in this and want to pursue it, and so there it is. Today we're going to talk about the number pi. This is one of the biggest reasons, probably the biggest reason when I look at the pyramid, that I think that it can't all be coincidental. There is something crazy out of whack with the generally accepted ideas, and it's purely because of the mathematics. Okay, the number pi, obviously different civilizations have arrived upon the number in different ways with different degrees of accuracy. We do have documentation about how the Egyptians arrived at pi, and this primarily comes from problem 48 of the Rhind Papyrus. Okay, this was written in 1650 BC thereabouts. This is actually, as far as we know, a copy of an original. It was written about 2000 BC. Okay, so that's maybe 5 or 6 centuries after the accepted construction of the Great Pyramid. So what I'm saying is that this idea that they had for arriving at pi when they wrote this down was centuries later than this. Okay, so this should be the most advanced, or this should be the most advanced way they have, because society tends to advance and not decline. Okay, knowledge tends to increase and not decrease. And so you go into that assumption, this should be 5 or 6 centuries ahead, technologically speaking, mathematically speaking, than the creation of this, because this came way after, hundreds of years. So anyway, I will not bore you with the details of how they arrived at it. I did that in a video I erased, but it just became too cumbersome. I can tell you that based on problem 48 of the Rhind Papyrus, first of all, there are no mathematical proofs. The Egyptians did not have mathematical proofs at the time of this writing. They didn't have mathematical proofs at the time the Greeks came around 300 BC to learn from the Egyptians. The idea of a mathematical proof was completely foreign. It was an alien concept. It was not even entertained. They just used they would look at several examples, and then they would make a general overall rule, and that was the way it is. There was no proof. They never offered mathematical proofs or anything of that sort. But anyways, using their method that they had come up with the number that was equal to about 3.16. This is the number that they would typically use for pi. And, the process is a little bit, they use a square and they cut the corners off of it and all these things. I'm not going to go through that. But this is what they ended up with, 3.16. That's actually a pretty good approximation for, a couple thousand years, actually 4,000 years before now. So they were about 18 1,000ths within pi. So they were very, very close. Now, if you look at the pyramid, and these measurements are indisputable, all right? And I have got different books, both Egyptology, accepted Egyptology books, and the crazy alien stuff. I've got that. I've got all of it, okay? The number that I'm getting this from, and you can get the same number from all of them. They all have the same number. But just for the sake of being as believable as possible, this is a mathematics textbook. It's called Mathematics, a Practical Odyssey. This is a math textbook that you can see used in colleges as of early mid-90s. I don't know if they still use it or not, but it is basically just it presents mathematics as a history. So it'll go through the various things for geometry and algebra and things like statistics and probability. It just covers a wide range. Okay, this is not an Egyptology book, plus or minus. This is pure mathematics. And this is where I'm getting my numbers from. Okay, so if you take the average of the size of the base, 755.78 feet is the average. If you add all these up and divide it by 4 to get the average, that's the number you get, 755.78 feet. All right, and the top, or the height of the pyramid, is 481.2 feet. Now, if you multiply the side by 2, the average side by 2, here, and divide it by 481.2, which is the height, you end up with 3.141230 all the way down. Okay, remember what I said, the Egyptians' understanding of pi was 18 1,000s, within 18 1,000s. Okay, this number here that you arrive at is within 4 10,000s, 4 10,000s. Okay, that is a several magnitudes higher level of precision than this. Okay, this is pretty good. This is insane. Okay, and so when you look at it, it's something that's nearly 500 feet tall, and it's got a 13.1 acre base. It's enormous. And when you calculate these numbers to get this ratio, and it ends up being within 4 10,000ths of the number pi. And you think that, okay, if this had been any taller or shorter, or if this base had been any bigger or smaller, this wouldn't be anywhere near. This would change dramatically, okay? So it is completely unreasonable to think that this is a coincidence. If you built 1,000 pyramids arbitrarily with no concern at all for the base to height, ratios and all this, you build 1,000 of them, you're not going to get anywhere near 4 10,000ths of pi. All right, it's just not going to happen. It is completely unreasonable to think that, and yet that is the Egyptological perspective, is that, oh, it's all a coincidence. Well, you know what? When you go into 8 million different coincidental numbers, you might be able to pick a lot of those out that are coincidence, because a basic geometrical structure is going to have some mathematical coherence that would lend itself to, patterns. And I get that, but not this. Not this. This is insane. Okay? This was what they had for pi. 3.16. And this, 3.14123, actual pi is 3.1415. Okay? It's too close. Alright? The only question is, were they aiming for this and just made a mistake that happened to be this? And that's more plausible, okay? I'm willing to accept that, okay, they were aiming for pi, what they thought was pi. And they didn't get to where they wanted to get, but it just happened to be very close to what it actually is. Okay, fine, there's a very little variance there. I would at least entertain that argument. But if you tell me that there is a complete coincidence, and none of this means anything, and it just happened to be this ratio between the base and the height just happened to be reflective of pi within 4 10,000ths, I'm going to call you an idiot. I'm going to call you a moron, okay, because that is not mathematically reasonable. So that's really it. I just wanted to kind of show, a lot of people may have heard this idea of the relationship of pi to the pyramid. I just wanted to show that and put that out there, especially in case I want to go a little bit deeper into this at a later time. So anyway, that's it. Thanks.